Okay, folks, section 9.3, solving problems with two variables. Now, remember, that's what we've been doing, okay? In the first section, we solved a system of linear equations. Each of them had an x and a y, right? Remember, a system of linear equations is two or more equations. We've just been dealing with two. Each of those equations has two variables, an x and a y, okay? We learned how to solve that system using the graphing method. We also learned how to solve a system using substitution. We want to use probably substitution. We don't want to try and graph these things, but we want to set up two equations for these word problems and use the substitution method to solve them. Okay, now you've been doing some of this. This isn't completely new to you, okay? Let's look at example number 1. It says John has 15 coins, all dimes and quarters. Okay, now you'll remember when we set up that equation, we say the number of dimes plus the number of quarters equals 15. We know that he has 15 coins, and D stands for the number of dimes, not what they're worth. Okay? Q stands for the number of quarters, not what they're worth. Okay? So we're just talking about the number of coins in this first equation. In the second equation, we're going to write this equation based on how much money we have. What is the worth of the coins, okay? So if I take the number of dimes and I multiply it by 10, that tells me how much money I have in dimes. Okay? Well, if I take the number of quarters and I multiply that by 25, that tells me how much money I have in quarters. Now, if I add the money I have in dimes to the money I have in quarters, that tells me I have 255 cents. Now remember, I can work with decimals, right? A dime is a tenth of a dollar, or $0.1. A quarter is $0.25, and my total would be $2.55. I can work with those decimals, or I can just talk about it not in terms of dollars, but cents. A dime is 10 cents, a quarter is 25 cents, and I have a total of 255 cents instead of $2.55. You guys have seen that, but I wanted to just go through it again. Now look at this. This is exactly what we did yesterday with the substitution method. Okay, I've got two equations. I want to take one equation and get a variable by itself. Well, it's easy to see that the red equation is the easiest one to alter. I'm just going to subtract Q from both sides and say that D is equal to 15 minus Q. Perfect. D equals that. That means that I'm going to take this and put it in place of D. All right? So it's going to be 10 times, not D, but what D equals. 15 minus Q. Okay? Plus 25Q is equal to 255. Beautiful. Now I only have one variable over there. See, it said solving problems with two variables. That means I want to be able to use two equations to write one equation with only one variable. This one has only Q's now. All right, well, let's distribute. 10 times 15 is 150. 10 times minus Q is minus 10Q. Plus 25Q is equal to 255. This is simple. This is simple, okay? Now we're going to combine the two Q terms, okay? That's going to give us 150 plus 15Q is equal to 255. Okay, now let's subtract 150, trying to get the Q by itself, right? So now I've got 15Q is equal to, that's 105, I think. Teachers. Right? I can't get part of a quarter. Let's go ahead and divide that both by 15. And that's going to give us Q is equal to, I think it's 7. 7 quarters. Okay? Now if Q equals 7, once I do that division, I'm going to plug that into this equation. Dimes is equal to 15 minus, not Q, but 7. All right? Dimes is equal to 8. 8 dimes, 7 quarters. Okay? I love it. That gives us $2.55. You can check it if you want. All right? Great job. Let's look at the next example.